Good. Today is October 29, 2025, and we are writing here in our schedule. We started the uniform circular motion. Okay, and I just corrected the report of your lab one. Let's see when is going to be the exam. The exam is going to be 2 weeks from now. But before the exam, we are going to have a holiday. Just before the day, the meeting, the Monday, just before the exam, is going to be a holiday, Veterans Holiday. We are right here. Okay, and by Monday, I'll let you know. The chapter should be 3 through 5. Let's see. Yeah, we should be able to finish chapter 5 Monday. Okay, and let's see, for the labs, material for the lab, at least lab number 1. Let's see if we have enough time to cover lab number 2. If you have enough time to cover lab number 2, I'll put it here. Okay, so that's the situation for the exam so far. And now let's take a look at the spreadsheets, right? At the correction of the spreadsheet. Okay, here is the insert page break. Today is October 29, 25, Wednesday. Okay, so okay, so first one, I corrected your first lab report. Okay, one. The correction of your lab report was posted to your group folder. Okay, 3. The correction of your lab report is a PDF file entitled P06L01 group XX, depending on your group number, right? So I want you all to open this PDF file. If you cannot find it, let me know. The grade, your grade is in between, your grade should be between 30% to, 30% to 100%. And it should be on the top of the document. I'm going to give you a sample of a correction of a lab report that was corrected in the previous years. And then if you have any questions, we can go through your correction. Let's see. Writing here, previous years, 2024. Let's see if I have it here in the format that I want. Correction. the previous, yeah, here you go. It's in, should be a file like that. Okay, this is a previous year. And if you have any problems visualizing, just zoom into it. But let me confirm with you all. Okay, the grade is right in here at the top, middle top. In this case, in the case of this group here, they got 85%. Okay. And all the tables are in there. In the case of this group, they they managed to get all the significant figures. For this reason, it's not highlighted there. Okay, they missed this CL here. They missed this CL. That's why it's highlighted in this color. Okay, and here is a list of what they missed. Your lab report should be, your correction should be like that as well. Okay, so if you have zeros here in the right side, it's a good news. It's good news because I'm not subtracting any points, right? And this group, they missed a regression equation in their graph, two regression equations. So I'm subtracting 6 points because they missed the regression equation. The CL, they missed only one CL. And for each CL that they missed, one pair of CL, right? And for each pair of CLs that they missed, I'm taking out 3 points. Okay, in the middle column. There should be 3 points for yours as well. And, and what else? Graph labels. In the case of this group of students, they missed the labels of the axis, right? The volume and cubic meters and the mass at cubic meters. They missed 4 graph labels. It was taking 1.5 points from each one of they missed. So I took out a total of 15 points. So the grade that was supposed to be 100 became 85. Okay, so you should have a correction like that, similar. That might be, maybe this middle column maybe is slightly different than what you have in there, but that's how you should look at it. If you have incorrect units and they didn't miss any units, this should be, let me get one that they missed the units. No, this one they didn't miss the units. Okay, this one they missed these units here. This group here missed this unit here. The slope was supposed to be kilogram cubic per cubic meter, right? They put 1 divided by cubic meter. So they missed the units of the slope and they missed the units of the percentage difference as well. That's why those 2 rows, those 2 cells are highlighted in red. Okay, here you go. See that? Incorrect units, 2 units that were incorrect. So and all the remaining units they didn't miss. Okay, it's a red. The code is a color coded correction, right? They missed some of the significant figures here, and the significant figure that they missed is in blue, light blue color. And you can go all the way down right in here. The color code, right? Incorrect units are in red. Missing significant figures are in blue. Significant figures that were added incorrectly is in green. Okay. And so let's see. The CL I color coded with the color. Which color is this one? It's not red. Is well, I do not know the name of this color, but it's slightly different from red. Okay. So those are the color codes that you have to worry about in your. Oh, here you go. See, I don't know which color is this one, but it's very similar to red. It's not red, but it's very similar to it, right? That's how I color coded the CL, the That's how I color coded the incorrect units, the missing significant figures, the added the significant figures that were added, the number of data points too, right? I color coded with this color. Nobody, I don't think anybody missed that. And the CL, I color coded with this one. Everything else is not corrected automatically. Okay, it's not corrected automatically. Everything else I have to correct on my own. Gotta look at the graphs, right, and see what's wrong with the graphs. Okay. So is that clear? So here you go. I'm gonna document that in my. Okay, your grade should be between 30% to 100%, and it should be on the top of your document. Okay, the lowest. If you turn in, here you go. Let's put this way: your grade should be between 0% and 30% to 100%. Okay, if you, here you go. If you turned in your spreadsheet, right? You got at least 30% in your grade. Turn in your, you got at least. If you didn't turn, otherwise, you got a 0. Okay? Like that. That's how I do it. And what else?
Professor, I have a question.
Yeah.
So I'm having a hard time finding the actual folder itself. I see the sheet, which is how I was able to do like the work, but the actual group folder, it's not showing up in my drive.
What's your group number?
Group number 4.
Group number 4. Let's see. Let me see if the other students are having the same problem. I can see, I can see your. Let's see here. Here you go. Group 4, right? Full
And you
folder.
shared the folder, right? Not just the sheet?
Yeah, here you go. Group 4. See that? The spreadsheet here, Excel spreadsheet is here, right? And
Right.
here's
I
the
can see the
corrected.
spreadsheet, but I can't see the folder itself.
Yeah,
So
okay.
all I can see is the spreadsheet.
Yeah, you're supposed to see it. Did you refresh your screen?
Yeah. Hmm.
Okay, so let's do something else. Close your browser, right?
Okay.
Close your browser. Go back to the folder again and see if you see it. And I want to check with the other students if they're seeing this PDF document. Okay. Sometimes
Yeah.
Google Drive has those odd odd behavior. Let's see here, roster right in here. Okay, now today is the 29th. Insert, good. So I'm gonna go through the Arturo Lagunas. Are you there, Arturo? I don't see Arturo here. Okay, so Arturo shouldn't be there. Jania Tapias. Jania Tapia. Let's see, Jania. I don't see Jania either. Let's see, Eric Alcala. Are you there, Eric? Yeah, Eric seems to be there.
Here.
Yeah, can you see your PDF file there in your folder, in your group folder, Eric?
Yes, I can see it.
Okay, good. Did you download the file to your hard drive?
Yeah.
Okay, good. So we have confirmation here that at least one student can visualize the PDF file. Let's see, Edith. Are you there, Edith?
Yes, Professor.
Can you see your file there?
Yes.
Okay, good. Were you able to open the PDF file?
Yeah.
Okay, could you see your grade as well?
Yes.
Okay, good. So another student that's in good shape. Let's see here. PDF file, right? PDF file. Yes. Yes. Next is Jawairia. Are you there, Jawairia? No, Jawairia is not there. Next is Arwa.
Yes, I'm here.
Okay, you're there, right? Can you see your PDF file there, Arwa?
Yeah. Yeah, I
Okay.
can see it.
Okay, that's good. Can you open it as well?
Yeah.
Okay, you can see your grade, everything, right?
Yes, I think so.
Okay, that's good. Next is Catherine. Catherine, group 2. I don't see Catherine here. Next is Ben. Ben Bundok, group 2 as well, right, Ben? Let's see. Can you hear me, Ben? Okay, Ben is not answering. Let's go to the next one here.
Ben said that he's in group 3. He messaged in the chat.
Ben is in group 3, right? Let me see here. Okay, in group 3. That's right. In group 3, can you see the PDF file there in your group folder, Ben? Yes. Okay, that's good. And what about Melissa? Melissa is here too, right? Can you see the PDF? Yeah. Okay, good. Can you see the PDF file there in the group folder, Melissa? Yeah. Okay, that's good. Delisha, group 4.
Yeah, I refreshed it again on my laptop and I could see it now.
Oh, that's good. That's good. Sometimes it's just a matter of refreshing or quitting your browser and going back again. It happens even to me. There are times that I try to see a file that I don't see, and I have to go through this troubleshooting. Okay, so let's talk to Isabel now. Isabel, doesn't look like Isabel is here, right? Isabel is not here. Queen Castaneda. I don't see. Oh, 2 students trying to get in. I see. Okay. I don't see Queen here in my list of students, in my roster. Yeah, okay. Next is Emily. Is Emily here? Oh yeah, Emily's here. I cannot hear you, Emily. Maybe you need to type it there in the chat window, right?
Oh, I said I can see the PDF.
Okay, good. Now I can hear you. Okay, Emily can see the PDF. Gabriela Edwards. I can see Gabriela here in my roster. Can you see the PDF file, Gabriela?
Yeah, I can see it.
Okay, that's good. And okay, Carlo Gallardo. Can see Carlo here. Group number 6, right, Carlo?
Yes.
Okay, so are you able to see the file,
Yeah, I
right?
can see.
Okay, that's good. Angelica Franco. Angelica is here. Can you see the file, Angelica?
Yes.
Okay, good. Princess Gabe.
Hello.
Can you see the file, Princess?
Yes, I can see the file.
Okay, that's good. Brandon Guerrero. Brandon is here. Can you see the file, Brandon?
Yeah, sorry.
Okay, so it works well, right? So I have been doing, I have been using the Google Drive since I have been using, man, I think I have been using this Google Drive since 2014, and it works very well. It works very well. I can upload the files there. I can download the files there that my students can visualize. Last year, I believe it was last semester. Yeah, it was last semester, not last year. I started doing that with Canvas and it didn't work. It just didn't work. Sometimes Looks like Canvas still has some problems in uploading and downloading those documents into their system. So, I tried Canvas last semester, uploading those documents to Canvas, and it didn't work. Now I'm going back to the Google Drive. Janie Maldonado. I don't see Janie here. Next is Kimberly. Kimberly is in my list. Can you see the PDF file there, Kimberly? Kimberly is group number 9. Okay, I don't hear from Kimberly. Let's go for the next one. Montserrat. Montserrat is here. Can you see the file there, Montserrat?
Yeah, I can see it.
Okay, that's good. Thank you. Nicolas Rivera. Nicolas is not here. Next is Jason. Jason Cervellon.
I'm here.
Okay, can you see the file there, Jason?
Yes, I could see it.
Okay, that's good. Thank you. Armand.
Yeah, I'm here.
Okay, can you see the file, Armand?
Yeah.
That's good. Let's see, Juan. Juan, I don't see Juan in my roster here. Next is Cecilia. Cecilia just joined us, right, Cecilia?
Hi. Yeah, I was here earlier, but I disconnected, so I have to rejoin. But yeah, I can see the PDF.
That's good. Thank you. And next is Jacob. Jacob is not here. Next is Evelyn Ayala. Evelyn. I don't see Evelyn in my roster. Next is Isabella Cisnero. I don't see Isabella either. Okay, next. Trin, are you there, Trin? I don't see Trin. Elizabeth Saldanha. No, Elizabeth Saldanha is not here either. So let's see if the number of students match with my roster 17. Yeah, I got everybody here. Okay, so that's how we are going to be doing the correction for the lab report. Okay, so this software I wrote myself using Excel. Okay, so here you go. I use how do you call it? A proprietary software that I myself wrote. Just of hard work, just lots of work. I spent, I'm going to share that with you folks. I spent 3,000 hours writing the software. Not just writing, but also troubleshooting it, make sure it works well, just lots of work. It was lots of work. I remember doing that. I started doing that back in 2014, okay? 2014. And nowadays, I spend like 3,000 hours writing the software, and now I save a bunch more of hours just using the software to correct your spreadsheets, okay? So hopefully this 3,000 hours that I spent has already paid back to me, okay? And I use a proprietary software that I myself wrote. Okay, and we will be using this type of correction, the software, for the rest of the semester. Okay, with color codes and grades automatically calculated, right? So on. And if you think there is a mistake there in the correction, let me know. Okay, if you think there is a mistake in the correction, please let me know. Please let me know. Okay. Sometimes the mistake is in the code itself, and I have to go back to the code and correct. Okay. And please let me know. Any questions? Any questions about that? what I'm going to do, I will type this lab grade in Canvas soon. Okay, and you will be able to follow your overall grade throughout the semester, with the exception, of course, with the exception of the homework, with the exception of the homework, which will be logged at the very end of the semester. Okay, with the exception of the homework, which will be logged at the very end of the semester. Okay. Any questions? It is 10:27 right now. Okay, and lab correction of lab report number 1. Okay. And what we're going to do now, let's see. Let's take a break right now, in case that you do not have any questions, right? Let's go back here. I don't think we'll be able to. Yeah, let's take a break, and then whenever you're back, we start lab number 2. We're not gonna cover this. We're not gonna lecture today. Okay. And we're going to use this meeting today to do the next lab. Okay. So let's log it here. Break 10:29 a.m. to, let's see, 10:44 a.m. So I see you in 15 minutes. Okay. Luxury. I am back now. Let me get something. I'll be back shortly. Hang in there. Okay. What I'm going to do now, I'm going to upload the spreadsheet for lab number 2. Okay. And keep on monitoring your group folder. Okay. Try this way here. First, let me check that everything looks good in the spreadsheet before sharing that with you. Okay, group. Let me see who is. Okay. Group 1. Here you go. Your spreadsheet's in there. Group 2. Your spreadsheet's in there. Group 3. Your spreadsheet's in there. Make sure you don't change the name of the file, okay? I want to keep the file with this name. Group 4, your spreadsheet is there. Group 5, Group 6, Group 7, Group 8, Group 9, Group 10, Group 11, Group 12, 13, 14. Okay, everybody should have their spreadsheet there. Make sure you download your spreadsheet. And I mean, download to your hard drive. Okay, I have uploaded the spreadsheet for lab number 2. Okay, here you go. 1. Make sure you download it. Download it to the to your hard drive, to your computer. Okay. And I'm going to walk you through this experiment. I'm now going to walk you through this experiment. This is experiment uniformly accelerated. Okay, so here you go. Here is the spreadsheet for group number 1. Okay, what this experiment is all about? This is an experiment on uniformly accelerated motion. Lab number 2. So the file that you have there again is okay, here you go. I gotta erase that. The file you have there in your group folder is P06L02GXX, where XX is your 2-digit group number. Please keep this file under this name and submit it. Please, let's see. Please submit when you're done. Please, when you're done, submit this file under this same name, okay? Do not change it. Do not change it. Do not change. Do not change the name. So what do you do when we perform this experiment? Okay, we determine the acceleration of a cart in an inclined track, an inclined track. That's how you do. In this experiment, you will determine the acceleration of a cart in an inclined frictionless track. This acceleration is then used to determine the acceleration of gravity. This is the 21st century, 21st century version of Galileo original experiments done. When did he do that? In the 16th century. Let's see. Let's take a look at Galileo Galilei, right? Galileo Galilei, those experiments on inclined planes were initially performed by Galileo Galilei, truly performed by him, right? And today, Galileo Galilei, here you go. That's the man, one of the great genius of humankind. He is the father of modern physics, of experimental physics, not modern physics, but of experimental physics. He was born during the age of discovery. The age of discovery started in the 1400s, in the early 1400s by the Portuguese, right? And so he should have done those experiments in the 16th century, 16th, 17th century. Okay. And if you go in Wikipedia, you can find out about his life and contributions. He made several contributions in physics. He was an astronomer, he was a physicist, and the father of observational astronomy, the father of modern era classical physics, the father of the scientific method, and the father of modern science. That for him, in order for a knowledge to be useful, it must reflect real life. That's what Galileo was doing. He was performing experiments, he was performing observations to explain the universe. And early life and family, you go name children. He had at least three children out of wedlock. Marina Gamba. One of them was Vincenzo, that helped him with his experiments. Okay, career and scientific contributions, seriously considered priesthood. Okay, he initially considered to become a priest as a young man. His father was urging him. At his father urging, he instead enrolled for a medical degree. His father urged him to become a doctor, medical doctor. And he was influenced by lectures of Girolamo Borro, all those guys here of Florence. When he was studying medicine, he noticed a swinging chandelier. That was a great moment in his life. Think about that. Everybody has watched a swinging chandelier. Even before Galileo, there were several people who noticed the chandelier oscillating back and forth due to air currents. But all those people that came before Galileo, they didn't give much credence to this type of motion. But it is with this type of motion that Galileo was inspired to study the motion of pendulum, which ended up becoming a very important device for mechanical clocks at the time, okay? But we're not talking about mechanical clock. You go pendulum here, okay? We're talking about the experiments on inclined plane that Galileo did. Let's see here, astronomy. Here you go. One of his contributions, right? He started observing the sky with a telescope. He didn't invent the telescope, but he improved it, and he started using it to observe the sky. Sunspot, here you go, still astronomy, theory of tides. Let's see if they have here inclined planes. Heliocentrism, he defended the idea, the heliocentric model of the universe, and because of that, he was persecuted by the church. Let's see if they scientific contributions, scientific methods. Let's see if they have inclined planes here. His very famous experiment in inclined plane pendulum, sound frequency, water pump, speed of light, Galilean invariance, falling bodies. Should be around here. Let's see. Time square, inertia, mathematics. They don't have it. Unfortunately, they don't have anything about the inclined planes. But let's see. Let me make a search here. Inclined. Oh, right in here. The falling bodies is closely related to inclined planes. Most of Galileo's experiments with falling bodies were carried out using inclined planes, where both the issues of timing and air resistance were much reduced. Unfortunately, they don't have a picture of one of the inclined planes that he used. Okay, but that's what the experiment that we are going to do today. Okay, this is the 21st venture of Galileo's 16th and 17th century. Original experiments on inclined planes. Inclined planes. At that time, Galileo didn't have good watches. Okay, so he had to rely on something else. He didn't have the same equipment that we have today. He couldn't completely reduce friction, but he used his imagination to make sure that friction would be reduced. And I want to get our illustrations here. Let's see if it's here. Correction P37. Yeah, accelerated motion. This one right here. Okay. So we start with a table. Okay, and here you go. What else? We have an air track as well. I do not know if you folks have seen an air track, but the first time I saw an air track working out, I was excited, because I have never seen. The first time I saw it was 1981. 81 was 40 years ago, like 44 years ago. And the first time I saw an air track, the experiment that we are going to describe today, with a cart in motion in this air track, I was excited to see something like that, because I have never seen a cart that would never stop moving. We would push the cart and the cart would move back and forth, would never stop, because the cart was floating on a air mattress, right? Was just like a hovercraft, just like the puck in your airtable hockey there at the arcades. So back in 81, we didn't have those toys, this type of toys. So it was really interesting to see that the cart moving back and forth without stopping. And that what the air track is all about. The air track is here to reduce the air friction between a cart and the track itself. Okay, so preparation. We're going to use the following equipment. I'm going to make a list of the equipment while we go through this description. Okay. The following equipment: 1, table, right? You saw the table. 2, a track with several holes throughout it, along it. The track has a triangular cross section. In case you haven't seen that, let's see if we have an illustration of an air track in the internet. Air track is the one that we have is made of aluminum. Air track experiment in physics. Here you go. Let's see, right in here. That's one of the pictures. Let's see if we can see. No, I don't like too small. Right in here. Yeah, that's the type of air track that we have. See the triangular cross section of the track? And then the thing can be like 2 meters long. And what we cannot see in this picture are the little holes. Let's see, let this guy go away. Air track and accessories.
For nearly frictionless.
Here you go. So this air track has a bunch of holes throughout its length, along its length, but we can hardly see those holes, unfortunately.
Use this air.
Let's see if we can see here. Yeah, the image is not very good. Doesn't have very good resolution in this image.
Results with plastic force and
but you have several holes in this air track, okay? And there is more to it. Let's talk about track with several holes along it. The track has a triangular cross section. What else? Here you go. A nozzle at the end of the track. An air track with several holes along it, and a nozzle. The track has a triangular cross section. Okay, next. This track has 2 legs separated by a distance b. An air track. Let me put here 1 with several holes along its length. 2, a nozzle at one of its extremities. Okay. The track has a triangular cross section. What else? Let's see here. No, not what I want. Cross section. D. Two legs separated by a distance b. I'm gonna put it. That's exactly the letter that I use in my spreadsheet. Okay, B is right in here in the first table. See first table. See first table of the spreadsheet. This distance is 1 meter, roughly 1 meter. See first table in the spreadsheet. What else do we need to know? You got a hose, right? Now should be a different item. A hose that is connected to the nozzle of the air track. Can you picture that? Here you go. And then this nozzle is connected to where? It's connected to an air pump. Okay, it's not a vacuum cleaner, right? A vacuum cleaner sucks the air. This pump that's the opposite job of a vacuum cleaner. It blow air through the nozzle, right? Creating this air flux through those holes. Okay. Air pump, an air pump connected to the hose to blow air through it. What else? Next, a cart, a glider. We call it glider because it floats just above the track. Okay, a cart. A cart that a cart with a triangular cross section. Cross section that fits on the top of the air track. Air track. Okay, and you saw there in the video. Let's go back to the video. How that air cart looks like. Here you go. Here's one cart. Here's another cart. Okay, it fits exactly on the triangular surface of the air track. This glider has a length L. We need the length of the glider. A cart or glider of length L. Okay. This cart has a triangular cross section that fits on the top of their track. Let's take a look at the L. It's right in here. C first table, right? C table 2-1. Here you go. C 2-1. What else? Well, what else you're gonna do? You're going to use a shim of thickness H. Here's the shim right in here to make sure that the track is inclined, becomes an inclined plane, right? Just like Galileo did back in the 16th and 17th centuries. A shim 6, a shim of thickness H that can be used to tilt the track. And now that your track is tilted, this object will be able to accelerate along it. There will be a component of the acceleration of gravity that will accelerate this track in this direction, right? In this direction. What else? You go. So those are, we need more. Here you go. Track and accelerate the cart, and accelerate the cart, like that. We're going to use also a micrometer to measure the thickness of the shim, and the thickness of the shim is displayed right in here. Remember that the micrometer, right, has a specific resolution. The micrometer has a resolution. We used the micrometer in the previous experiment, right? Let's write it down. We used the micrometer in the previous experiment. And the resolution of the micrometer is, right? Remember what the resolution of the micrometer? Is 0.00001 meter. Okay, it is 0.01 millimeters, 0.001 centimeters, right? And then we add 2 more decimal places to display the resolution of the micrometer in meter. And let's not forget, we will always be using the unit, the main SI unit. And then I gotta tell you about the other lengths too, how they were measured, right? Let's see here. The first length that I mentioned to you was B, okay? This length is measured with a ruler. Okay, let's see. It's a ruler having a resolution of 1 millimeter, which is 0.1 centimeters, which is 0.001 meter. Okay. Let's do the following. Let's put here at the top, okay, a ruler. I'm going to put the ruler there at the top. You go, a ruler having a resolution of, no, not a ruler, a meter stick, right? Having a resolution of 1 meter. A ruler is very short to measure lengths greater than 30 centimeters, right? So you would be using a meter stick having a resolution of 1 millimeter, and also a ruler also having a resolution of 1 millimeter. Okay, so here you go. The separation between the 2 legs, this length is measured the meter sticker. This length is measured with the meter stick. Here you go. Air pump, a cart or glider of length L. The length of the cart is measured with the ruler. Okay. And here you go. I'm gonna put this one at the top too. Here you go. A micrometer to measure. A micrometer with a resolution of 0.01 millimeters. And now I can mention that the thickness of the shim of thickness H that can be used to tilt. Okay. The thickness of the shim. The thickness of the shim is measured with the micrometer. Okay. And the thickness will be displayed like 1, 2, 3. How many? 5, right? 5 decimal places. 1, 2, 3, 4, 5 meter. Here is millimeter. Yeah, that's right. 5 decimal places. And we have 5 decimal places here. Yes, 1, 2, 3, 4, 5. Yeah, we also have 5 decimal places. What else can I put it here? 2 legs separated by this length is measured with a meter stick and displayed with the following decimal places. You know, X dash 1, 2, 3 meters, right? Same thing for the lengths of the cart. And here you go. And display the following decimal places. Going back to my drawings here. Here you go. So we have a tape attached to the air track as well, measuring tape. And we can see this measuring tape right in here. See, that's the measuring tape. This track is exactly the same we have there at the LA Harbor. So let's put the measuring tape as well. Measuring tape. A mesh on air track. And I'm gonna put here a nozzle, a measuring tape attached to the air track with a resolution of 0.001 meter. Okay. And what did I do here? I basically put my axis, right? My x-axis along the air track. Notice that the x-axis is inclined with the track. What else we're going to use? We're going to use a photo gate. A photo gate. And I'm going to tell you what a photo gate is, okay? A photo gate at position Y. Now see table, see spreadsheet. See spreadsheet. And let's see which table is this one. Here you go, position Y. Right in here. Table 2-2. See table 2-2 in the spreadsheet. See table 2-2 in the spreadsheet. What is a photo gate? Okay, the photo gate is a fancy timer or a stopwatch. A stopwatch with a very small resolution, of 0.1 milliseconds. Okay, 0.1 milliseconds is 0.0001 seconds. It's better than your cell phone, right? You have the timer in your cell phone. Timers in our cell phone usually 1/100th of a second. So this, timers, this resolution is what? 1, 2 is 3 orders of magnitude better than the resolution in the timer of your cell phone. Okay? That's what the photo gate is all about. Okay. The photo gate behaves in the following way. Let's see if I have oh yeah, here you go. I have an illustration here of the photo gate. The photo gate behaves in the following way. It has an LED at one end, okay? And it has a photo detector sensitive to the light coming out from the photo gate, from the LED, coming out from the LED. When this beam is interrupted, the photo gate start timing. It's like pressing the button of your timer in the cell phone. Okay. So when this beam is interrupted, the photo gate start timing. Okay. So here you go. The photo gate is made up of an LED. Actually, it's an infrared LED. We cannot see the light of the LED. Infrared LED at one end and a photo detector at the other end. This LED produces a beam of light that is used to time, that's used as a timer, When the beam of light is interrupted, the timer turns on, okay? So it's just like pressing the button of your stopwatch. Okay. The photo detector is something that can detect the light. It's like an eye. It's like an artificial eye, okay? So let's write that down. I'm going to copy and paste what I have here because I think it's a good, here you go. For photo gate at position Y. What is the photo gate? It's a timer or a stopwatch with a very small resolution, with a very small time resolution. Time resolution of 0.1 milliseconds. And here you go. The photo gate has the following components. Here you go. The following components: an infrared LED, a photodiode sensitive to the infrared light. The photodiode behaves just like the human eye. It's like an artificial. Behaves just like an artificial. Here you go. Artificial human eye, and it's used to determine if the infrared light is on or off. It also has an LED indicator, a red LED indicator, where you read the time displayed by the photo gate. When the beam of light between the infrared LED and photodiode is interrupted, the red LED turns on. The red, let's see, the indicator, a red indicator, don't put red LED, it's not necessarily an LED, a red indicator display when the beam of light between the infrared LED and the photodiode is interrupted. The indicator display turns on and and start displaying the amount of time, okay? What else do we do? Here we go. Photogate at position Y, huh? Let me put this way here. Here you go. The position Y of the photogate is measured 5 different times. See table. Okay? 2-2. And let's go back to the table. Here's the table. 1, 2, 3, 4, 5. Okay, we make 5 measurements of this position of the photogate. We sum all those 5 positions and take the average value that we are going to use in the experiment to determine the acceleration of the cart. Okay. The photogate is a fancy timer or a stopwatch. It's a very small time resolution. The photogate has the following components. Okay, red indicator display. Let's see if I have a picture of the photogate for you. This video must have the photogate. Let's see if she has a photogate here. No, he doesn't have the photogate. But let's play just a little bit this video. Here you go.
For nearly frictionless mechanics demonstrations, use this air track.
Here you go. Here is the nozzle of the air track, and here's the hose that goes to the pump. Okay, this white pump on the extreme left. Our pump is exactly the same that they have here. Okay, so here you go.
Available from Flynn Scientific. This durable and reliable air track system is designed to obtain accurate results with classic force and motion experiments. The 1.6 meter air track.
Oh, here you go. Now we can see the holes. See the holes here? Now we can see the holes in the air track. The air is pumped through this hole and levitates the cart to decrease the friction.
Up and level. Then simply attach an air source
Here you go.
and you are ready to go. Flynn's air track includes 1 small and 2 large gliders, all with steel bumpers.
Yeah,
a
that's
rubber
just
band glider launcher.
okay. We can stop here, just like a advertisement, right, for their products. But now you have an idea how the air track behaves. Let's take a look at the photogate. We're talking about the photogate, right? Let's see. They don't have a photogate here, but we will be able to find one here. Photogate timer. Here you go. YouTube. Okay, our photogate is much like this one. Let's see. I want to see one that is used as that. Oh yeah, right in here. That's not exactly the way. Okay, the one that we use is this one right in here. Oh man, stop it. Let me.
Trilhões de ideias para fazer a mensagem chegar no
Skip.
Hey guys, Mr. Johansson here. We're at the dynamics track.
Here you go. That's the photogate here I'm talking about. It's not a red display indicator. It's a black and white. Let me check. Let me correct that. The photogate that we have is exactly this one here. An infrared LED, a photodiode sensitive, an indicator, a black and white indicator display. When the beam of light between the is interrupted, the indicator display turns on and start displaying the amount of time. Okay. Now, black and white. We also have, here you go, a red LED at the top of the photogate that indicates when the beam of light is interrupted. So we have all those 4 components in the photo gate. Here you go. Here, the photo gate, see the zeros right in here? Let me blow up the image. The zeros here, it's still, it's not timing, right? Here is the jaws of the photo gate. At the tip here of this jaw, we have an LED that projects a beam of light towards the other end, and the other end has this photodiode. When I interrupt this beam with my hand or with the cart itself, this timer starts. This timer starts, okay? That's how it works. What time is that? 3:37. Let's keep on moving. The red LED at the top of the gate that indicates the beam of light. When the beam of light that turns on when the beam of light is interrupted. So 4 different elements for the photo gate. Infrared LED, photodiode sensitive to infrared LED, a black and white indicator display, and a red LED at the top of the photo gate that turns on when the beam of light is interrupted. Okay, so we don't need that anymore. We talked about the Y measurement. The Y measurement, let's see, okay. The position Y of the photo is measured 5 different times with the tape measured attached to the air track. Okay, resolution. So X meter, right? With 3 decimal places in the measurement. What else? Let's see. What else we need? Here you go. Photo gate at position Y. So here you go. So we release the cart, right? And the cart slides and passes through the photo gate. Passes through the photo gate. The length, the photo gate is going to measure the time it takes for the cart to go completely through the photo gate. Okay, let's see. Here you go. I don't have a nice. Let me put here a. I'm going to do like that. Here you go. Photo gate on. Photo gate off. Okay, like that. The moment that the cart passes through the photo gate, this beam of light is interrupted, and it measured how long it took for the cart to go completely through the photo gate. Do you get the idea? The length of the cart is L. Here you go. Let me do another frame here in my movie, right? Here you go. Another frame here in my movie. One more. Hi, heck. One more frame. Okay, and now here you go. We release this cart from position X. The front bumper of the cart is position X. Let's take a look at X here in the spreadsheet. Here you go. That's the initial position of my cart. See, right in here. Position X. We turn on the pump, right? There is no friction whatsoever. The cart slides the track. When it's about to cross the photo gate, the photo gate turns on, the cart goes completely through it. Let me do another, here you go. Photo gate is on, right? Here you go. Photo gate is on, photo gate is still on. The cart passed completely through the photo gate turns off. And it times how long it took for the cart to go through this photo gate. Let's put another frame here. Here you go, another frame. That's how the experiment is performed. Okay, and I'm going to, here you go. Photo gate is on. Photo gate is on. Photo gate is on. Photo gate is off. Photo gate is off. Now we can play the movie, right? Here you go. Photo gate is still off here, right? I want to put the photo gate off in every place here that we have. Photo gate is off. Photo gate is off. Photo gate is off. Photo gate is off, right? Here you go. Down the hill. Photo gate is off. Photo gate is off. Photo gate is on. The cart is interrupting the beam of light. While the cart is traversing the photo gate is still on, and it's timing how long it takes for the cart to go completely through that. Once the cart completely passes through the photo gate turns off. Okay? That's how this experiment is performed. And here you go. At different positions X, here you go. That's the time that the photo gate is measuring. Don't forget to display it with the proper significant digits, right? And then we vary the initial position of the cart. The initial position is here, and then let's see, the other one, we repeat the experiment for a different position. Here you go. Here's another position. Okay. Repeat, let's do. Is a total of how many initial positions? Is a total of 10 initial positions. Initial position 1. I can even put it here. Initial position 1. Lower, here you go, subscript. Initial position 1. Right? Initial position 2. Initial position 2 is going to be a little bit downhill. And then we have initial position 3, a little bit downhill again. And so on, right? And so on. That's what we have here in this spreadsheet. Initial position 1, initial position 2, 3, 4, 5. And for each initial position, it's going to take a longer amount of time because the cart is accelerating for a smaller amount of time. Okay, you can see that for the initial position 1, it takes 0.1949 seconds for the cart to move through the photo gate. For the next one, it takes a little bit longer because the cart is going to have an average speed through the photo gate that's going to be less than before, okay? That's what we have. So let's write that down. Photogate has the following components. Okay, here you go. That's the description of the. That's the description of the equipment. What time is that? 11:45. Let's go a little bit longer. Let's see if we can finish before our break. The following equipment. That's the equipment. Now, what about the procedure? The procedure, experimental procedure. Restart, right? Experimental procedure. Okay. Incline the track with the shim. Connect the hose to the nozzle of the track. 3, turn on the air pump. Did I put air pump here? Yeah, air pump. Turn on the air pump. 3, position the cart at the very top of the track and write down the, okay, at the very top of the cart. Here you go. Write down the position of the front bumper of the cart. That would be X. Okay, here you go. Release the cart. After cart goes through the photo gate, write the amount of time that it took for the cart to move completely through the photo gate. Through the photo gate. So let's see, let's write better. Write the amount of time, release the cart. Write the amount of time that it took for the cart to move completely through the photo gate. Okay. 8. Repeat steps 4 through 7 for 9 different initial positions. Okay, X. That's what the steps are all about. Let's see if you have anything else I gotta tell you. Yeah, that's it. Right? So let's refresh before we go into our break. Here you go. Table. We start with a table. It's lots of steps, right? Those experiments, if you're doing the experiment for the first time, is rather difficult to do that, because if there are lots of steps associated with that, an experiment like that takes roughly 3 hours to perform. So here you go. Air track, nozzle, distance between the 2 legs of the cart, of the track. You're going to need that. I'm going to explain to you why, because there's a theory behind that. The hose connected to the nozzle, a pump connect to the hose. Measure the length of the glider with a ruler. Use a shim to tilt the air track. You have to know the thickness of the shim you measure the thickness of the shim using a micrometer. Okay, now turn on your pump, position the glider at the top of the air track. Don't forget that we have a tape attached to the air track. which serves as our x-axis, okay? Position a photo gate somewhere along the track. This is our initial position. Release the cart. The moment the cart passes through the photo gate starts its timing, its timer. Photo gate is on. Here you go. Cart going through the photo gate, right? Cart exiting the photo gate. The average velocity of the cart is going to be the length of the cart divided by the time measured. And so let's take a look here. Here you go. The average velocity of the cart, right? That's a 1, 2, 3, 4th column. 1, 2 time it takes for the cart to move through the photo gate. Initial position of the cart. D. What's D? D. Okay, D. I know what D is. D is the delta x. Is the y minus x. Okay? Delta is the delta x. D is this distance here. Let's see here. D, lowercase d, right? Lowercase d is the distance between the front bumper of the cart and the position of the photo gate. Okay? Between here and here, the cart is going to be accelerating, right? Its speed is going to increase from 0 to whatever. So we need this delta x. The velocity of the cart is going to be the length of the cart divided by, here you go, the length of the cart right in here. Divide by the time. And then we are going to need the v square as well. I'm going to tell you why we're going to need the v square. Let's see. We use the following formula that we derived in class. We use this formula here that we derived in class. Okay. The velocity, the average velocity, here you go, the average velocity of the cart. The average velocity of the cart through the photo gate is, okay, there is another formula here. Average velocity, here you go. The average is L, length of the cart, divided by the time measured by the photo gate. So we calculate this average velocity right in here. Then we take the square of the velocity. The average velocity is, okay, and then what else? We find the acceleration of the cart using the following formula we saw in class, right? The Torricelli equation. The initial velocity is 0. That's why I have 2a delta x. Delta x is that the distance d that you saw, right? So here you go. Like that. And when I replace by the letter d, that's in the, and then what else? What else do we do? We plot v squared versus d. Plot v squared versus d. Okay? In the graph. That's the graph we are going to plot versus d. The slope of the graph is equal to what? Is equal to 2 times the acceleration. Consequently, the acceleration is going to be given by the slope divided by 2, right? The slope of the graph is related to the acceleration according to the equation, like that. Hate that. Oh my goodness, I don't know why my computer behaves in this way. I gotta figure out a way how to fix that. Here you go. That's the slope, right? And the acceleration that we want to find out is going to be half the slope. What time is that? That is 11:57, almost 12 noon. What else? Let's see if we can take another 3 minutes to finish this theory. And then there is a relationship that is then, that is a relationship between this acceleration and the acceleration of gravity. The relationship is this one here. Here you go. A, acceleration that we found. B, the distance between the two legs, and divided by h. H is the thickness of the shim. Okay? Let's take a look here. And all these formulas are already programmed in my Excel right in here. Here you go. Here's the acceleration. Here's the slope, right? That you're gonna, no, sorry. Here's the slope that you're gonna log in. The acceleration is half the slope. And the experimental acceleration of gravity is A times h17, which is B, divided by h, which is f17. Finally, we get a percentage difference between your experimental G and your theoretical G. Your theoretical G that is here. Okay? So it is 11:59 a.m. right now. That's the whole thing that you need to know about this experiment. Okay. And let's go for our break right now. Any questions? The whole thing is, is already recorded.
Professor, this is recording, right?
It's being recorded. Unless I forgot.
Great.
Did I forget to record? Let's see if I forgot to record. Hopefully I didn't. No, I didn't. Okay, I'm recording. Yeah. I'm gonna pause recording now. Okay, I'm back here. Now, the first step that you want to do, right? Just plot. Let's share the screen. Steps. Plot v square along the y-axis and d along the x-axis. Have you done that already? Go v square and d along the x-axis. Okay? Just one plot, just one graph. And look what we get. We do get a straight line. Remember, this is real life data, right? real life data. And you are going to fit a straight line to this graph, display the equation on chart, display the R square on chart. Everybody should be doing that. And don't forget to do everything that you need to do, right? Label the X and Y axis. And don't forget, you have to optimize this graph as well. Don't leave this big, huge blank area. Okay. What else you have to do? Here you go. Log the slope into the left table. The slope of your graph. Check the percentage difference for the experiment, for experimental value of the acceleration of gravity. It should be a small percentage difference. Fill up the units on the table. Display the proper number of significant figures. Find the CL, right? And that we need to have anything else. Here you go. Find the CL, fill the rest, right? Find the CL. So that's where. Let's go through each one of you to see if you have any problems. Okay, let's start with Eric Alcala. Are you there, Eric?
Yeah.
Okay. I want to know if you got a. First thing is if you download the spreadsheet. Did you download the spreadsheet?
Yes.
Yes. Okay. Now the next is if you plot the graph. Did you plot the graph?
I'm not done yet.
Not done yet, right? So working. I'm gonna put it here that you're working. Edith, are you there? Okay. Did you download the spreadsheet?
Yeah, but I haven't been able to plot my graphs yet. I'm working on it.
Okay, good. So just put the W here, working on the graph. Jawaida, are you there? Jawaida, I don't see Jawaida here. Okay, let's put O. Next is Awa. Are you there, Awa? Awa is not there either. Okay, let's go for the next one. Catherine. I don't see Catherine. Next, Ben Bendoy. Hello, Ben. Were you able to download the spreadsheet? Let's see, I have a message. Okay. So what about the graph? Were you able to plot it as well? Okay, so you're working. Melissa, were you able to? I don't see Melissa here. Yeah, Melissa, looks like Melissa left. Okay. Next, Delisha. Were you able to download the spreadsheet, Delisha? Okay, I'm not hearing from Delisha. So put a little star here. Isabel. Isabel is not here either. Queen Castaneda, I don't see Queen here. Next is Emily. Emily is not here. Emily. Next, Gabriela. Did you download their spreadsheet, Gabriela?
Gabriella said that she downloaded it.
Okay, what about the graph? Did you plot your graph? Oh, downloaded. Oh, working on the graph. Okay, good. Okay, just now that I saw your chat message. Thank you, Gabriela. Next is Carlo Gallardo. Did you download your spreadsheet, Carlo?
Yes.
Okay, did you plot your graph?
No. Can you show us how
Yeah,
to plot it again?
let's do it again. Here you go. I'm going to erase it. Here you go. Highlight V squared, right? If you're using a Windows computer, press the Control key and highlight D. Okay? Now they're both simultaneously highlighted. You go to Insert, Chart, Scatter Chart, and then you plot your graph. Okay. In the next step, you click one of the data points of the graph, right-click it, add trend line, and check display equation chart, display R square on value on chart. That's how you do it. Okay. So that's Carlo, right? You downloaded and you're working on your graph. Princess, were you able to download your spreadsheet?
Yes, I was able to download it.
Did you plot your graph as well?
Yeah, I plotted it just now. I'm just trying to put in the equation
Okay.
on the graph.
In the tables, right?
Yes.
In the table. So after plotting the graph, get the percentage difference, right? That's what you have to do after plotting the graph. Next is Brandon Guerrero. I don't see Brandon here. Looks like he left. Let's go for Jenny. Jenny is not here. Next, Kimberly Morales. Okay, did you download your spreadsheet, Kimberly? You said yes, right? Okay. What about the graph? Did you plot it?
Working on it right now.
Okay, working on the graph. That's 12:30 right now. Okay, Montserrat. I don't see Montserrat here. Next is Nicolas Rivera. I don't see Nicolas. Next, Jason. Jason Savillon.
I was able to download it, and I was just wondering how to add the trend line on the chart.
So, were you able to plot it?
Yes, I was able to plot it.
Okay, good. So now you gotta get your percentage difference. Did you get your percentage difference?
No, I don't know how to get that.
Okay, you have to, what do you have to do now? Here you go. You get your slope here, right? Point, in my case, it's
Yes.
0.2621. Go to the bottom table, and then you fill up here the slope value, 2621. Okay?
Okay. Okay, thank you so much.
I'm getting just a 3% difference. Don't forget to fill up the units as well.
Okay, thank you so much.
Okay. We'll get back to you later on. Armand, are you there? Let's see if Armand, yeah, Armand is here. Did you download your spreadsheet, Armand? Okay, I cannot hear from you, Armand. I will get back to you later. Let me put here a star. Next is Juan Torres Arellano. Okay, now Juan is here, right? Hi, Juan, did you download your spreadsheet? I don't hear from you. Cannot hear from you, Juan. Are you there? Okay, let me put a star here. Juan is group number 11. Let's go for group number 12, Cecilia. Did you download their spreadsheet, Cecilia? Oh. Cecilia must be away from her computer. Are you there, Cecilia? Okay, let's put a star here on Cecilia's name. Who else? Jacob Contreras. Is Jacob Contreras? No, Jacob's not here. Evelyn Ayala. I don't see Evelyn either. Let's see, Isabella Cisnero. I don't see Isabella Cisnero here. Trin is not here. And Elizabeth Saldanha. No. What about Edith? Let's see, I didn't call Edith, right? Edith just joined us, right, Edith? Let's see, where is Edith here? Okay. Oh yeah, I talked to Edith already. Okay, good. So I'll give you a little bit more of time to work. Okay. Don't forget, after you plot your graph, make sure you log the slope in the last table, right? This row here is values. This row here is units. So make sure you don't mix them up. Okay, so 15 more minutes to go. Let's see how is everybody doing there. Going back to Eric. Did you plot your graph, Eric? Eric's no longer here. Okay. What about Edith? Did you plot your graph, Edith?
I'm doing it right now, but since I'm on a MacBook, it's just taking a little longer since I have to do it like manually.
Uh-huh. Okay, so you're working on that, right?
Yes.
Okay, thanks. Let's see who else. Jawaida is not here. Arwa is not here. Next, Catherine's not here. Ben, did you manage to plot your graph, Ben? I'm plotting, but won't load. The chart won't load. Okay, so must be a problem there with your laptop, right? Or laptop or your desktop. So keep on working on that. We have, do you need any help with this graph, Ben? Okay, this is your Wi-Fi. Okay, so I'll get back to you later. If you need any help, let me know. Melissa? Melissa is no longer here. Next is Galatia. Are you there, Galatia? Looks like Galatia is away from her computer. Next, Isabel is not here. Next is Queen. I don't see Queen. Let's see Emily. Emily is not here either. Let's see Gabriela. Looks like Gabriela left as well. Next, Carlo Gallardo. So did you manage to plot your graph, Carlo?
Yes.
Yes. Okay.
Yeah.
Did you log in the slope there in the last table?
Well, I tried to, but I think my computer's a little laggy right now.
Uh-huh.
I'm gonna try to like see what's wrong.
Yeah. So I'm gonna put here working on that, right?
Yeah.
Okay. 12 more minutes to go. Let's see. Next is Angelica. Did you plot your graph, Angelica?
I'm still working on it. I think my Wi-Fi is slow.
Okay. Let's go, Princess. You plot your graph, right? And now,
Yeah, I did plot my graph.
so you gotta log your slope there in the last table. Did you do that?
I did log in my slope in the last table.
What's the percentage difference you're getting?
The percentage is the percentage difference supposed to be the last box on that table on table 2-5?
Here you go. This table, yeah, 2-5.
Okay.
If you log your slope here, you're going to get this percentage, a percentage difference. Okay.
Okay.
Watch for this one.
For that one, I got 4.1572.
Okay, good. 4.15. Okay. 4.16%. That's good. Okay, so now what you have to do now? Now I want you to work on the units, right?
Okay. Yeah.
The units there of that's Princess. Let's go for Brandon. Brandon is here. Nope. Next is Jenny. Jenny is not here either. More Kimberly. Is Kimberly? Yeah. Did you manage to plot your graph, Kimberly?
No, I'm having issue with my computer right now.
Uh-huh. Okay. See if you can fix the problem, right? And let's see. 10 more minutes to go. Let's see everybody else here. Kimberly. No, Montserrat is not here. Next is Nicholas Rivera, not here. Jason, did you manage to get your percentage difference, Jason?
I'm working on it right now.
Okay. All you gotta do is to type, right? You type your slope here in this cell, and then you read this number. Okay?
Okay, thank you.
Okay. Working. So Jason is working. And this one. Armand. Armand, are you there, Armand?
Yeah, I'm here.
Okay. Did you manage to download your spreadsheet?
What?
Did you manage to download your spreadsheet? The spreadsheet
Yes.
for lab 2?
Yes.
Yes, okay. Did you plot your graph?
Not yet.
Okay, so you're working. Okay, so here you go. You're working on that. Juan is Juan there. No Juan left. Let's see, Cecilia.
Yeah, I plotted it. I'm just working on the percentage difference.
Okay, so you're working all you got. Okay, good. Jacob, are you there? No, Jacob is not here. Evelyn Ayala is not here. Isabella is not here. Trin is not here. Elizabeth Saldanha, we have two. Okay, we have Elizabeth Saldanha. Now, let's see. Edith, right? Let me go back to Edith. Here you go, Edith. Did you plot your graph, Edith?
I kind of got stuck because my MacBook, I don't know, like it wasn't plotting it correctly, so I'm like redoing it all right now.
Okay. Okay, so
Yeah.
if you need any help, let me know. Okay.
Thank you.
Let's see, next. Oh, the other one, Eric is not here. Arthur is not here either. Okay, next. Ben Bandoy. 7 more minutes to go. Did you plot your graph, Ben? Let's see here. Won't load, huh? Okay, so go ahead, restart your PC, see if you can fix this problem, right? And the next one is Melissa. Melissa is not here. Delisha? Are you there, Delisha? Okay, Delisha must be away from her computer. Next. Did you get your percentage difference, Carlo? Carlo Gallardo. Oh, Carlo Gallardo is not here. Okay, next. Angelica. Did you plot your graph? Did you finish plotting your graph, Angelica? Manage to plot your graph? Okay, I cannot hear from Angelica. Let's try someone else. Princess.
Oh, sorry, I'm lagging. What did you say, Professor?
Yeah, is that Angelica?
Yes.
Okay, did you plot your graph?
Not yet. My Excel is stuck. So, yeah.
Okay, make sure you install the Excel in your hard drive, okay? Maybe that's why it's like that. You cannot run it from the cloud.
Yeah, it's just my Wi-Fi because they're working on my Wi-Fi, like my neighbor's Wi-Fi, so they had to, yeah, so I'm on hotspot right now.
Okay. Okay, thank you for letting me know. And Princess, are you there, Princess?
Yeah, I'm here.
Okay, did you get your percentage difference?
Yeah, I did get my percentage difference.
How much was that? How much is that?
0.15.
Oh, yeah, you already told me that. Okay, good.
Yeah.
Thank you for letting me know again. For some reason, I erased it here from my. What about the units? Are you working your units?
Yeah, I'm working on the units right now.
Okay, good. Next one, let's put here W for working. Oh, next is gonna be Brandon. Brandon is not here. Jenny, are you there, Jenny? Jenny is not here. Kimberly. Kimberly, you're working your graph, right?
Yes.
Did you, were you able to plot it yet? Not yet?
No, I'm having issue with my Wi-Fi as well.
Oh,
I don't know
well.
what's going on.
Okay. Okay. So let's go to the next one. Armand, back to you, Armand. 3 more minutes to go. We're running out of time, right? If you don't do it now, you can do at home, of course. You can work
Yeah,
at.
I'm just a little confused. That's why, but I'll get it.
Yeah, but what's the, how confused you are? Tell me exactly what's the problem.
I'm just trying to, just because remember I'm doing my MacBook. I'm just trying to because I did it before, but I'm trying to figure out how to make the graphs again because it's not working again. But
Okay, so let me just walk you through quickly here, right? Here you go. You highlight, right? Here you go. You highlight the V square, the numeric values of V square. If you're using the Mac, you press the Command key in the Mac and highlight the numeric values for D. That's what you have to do. Did you try that?
yeah,
Okay, is it highlighting?
yeah.
Okay, now you go ahead, go to the top, insert, right? Chart, and you get the plot. Did you get the plot there?
I'm inputting it right now. Hold on. Yeah, I have the same issue as last time. I have to do it like manually.
Uh-huh. What do you mean do manually?
Like I have to go and insert, and then after I should plug in the values for every plot. That's what I did last time.
Mhm. You are group number, let's see here. Group number 11, right?
Yeah.
Okay. Okay, I'll give you more time. Let's see, 1 more minute to go. Let's see here. Armand, thank you for.
Professor, how do you get the percentage? I got
What
my slope now.
you got a percentage?
How do you get the percentage? Like, where do I insert it?
Okay, here you go. Here's the spreadsheet, right? Here's the spreadsheet. So here you go. You gotta get the regression equation, right? Did you get regression equation in your graph?
Yes.
And the R square. And then look at the number here for the slope. Look for the slope, right? You memorize this slope and then you log the value of the slope here in this cell of table 2-5, right in here. Okay? Percentage difference is going to show up right in here. I'm going to put here 25.2521, which was my slope, right? My slope was 2521, no, 2621. 2621. And look here, I'm getting a 3%, difference.
Oh, because mine is greater than 3%. That's why.
But yeah, but how much? How much? Yours, how much percent are you getting?
8.30.
Okay, which group are you?
9.
Group 9. Okay, let me get your spreadsheet. Your spreadsheet is different from this one, okay? It's okay if it's different. Here you go, group 9. Now I'm going to plot the graph just like you did yours. Insert. chart. Here you go. Right click, add trend line, display equation chart. I'm getting the same. Interesting. 2621. Okay, I'm getting the same slope that I got before. Let's see here. Yeah, 2621. Let's see here. 0.2621. Yeah, I'm getting 3%, and that's your group 9, okay? You're getting, I gotta see what's happening there. Maybe you erase the formula, I do not know what's happening. Do you have this value here, 9.82? Make sure you have 9.82 here in this first table. Okay. It's 12:51 now. We run out of time. Okay, work as much as you can on your own. If you need any help, just show up during my office hours. And by the way, this spreadsheet is lab report for lab 2. 2 is due next Wednesday. Next Wednesday is going to be, November 5th, due November 5th, okay? 25. And we're gonna have daylight saving, going back, right? Going back on daylight saving, okay? So if you don't have any questions, I'll see you Monday again.
Thank you, Professor.
Thank you, Professor.
Welcome.
Professor, you have videos on lab 2 on your YouTube, right?
If I have videos on lab 2, yes, I have from last year.
Okay, I'll just check it out. Thank you.
Yeah, let's see. Stop record. Let me stop record.